valve, like any other piece of equipment, needs regular inspection during operation and prompt attention when trouble develops. Many shut-off valves are never operated during normal plant cycles. These might be equipment isolation valves or emergency valves which were originally installed for personnel or equipment safety. Such valves must be operated occasionally or they may deteriorate with time. It would be well to operate each valve during an idle period just to see if it actually works. This would detect trouble before complete failure, save repair costs, and possibly prevent damage to other equipment. Normally, there should never be a need for the use of a bar or a wrench to open or close a valve. However, two things are necessary before valve wrenches can be done away with. First, an adequate valve maintenance program must be carried out. As soon as possible after a valve develops trouble, make necessary repairs. Secondly, a valve must be treated with respect and in the proper manner. Valves are quite rugged pieces of equipment and will stand abuse, but care should be used in operating them to get the best service. If a valve leaks slightly when shut off, open it a little to flush away any particles which may keep it from seating. Don't try forcing it shut with a bar, as this can completely ruin the seat. A closed valve should be closed tightly and not left to leak, thereby cutting the seating surfaces. Closing a gate valve can be a special problem, and the larger the valve, the larger the problem. If a gate valve is closed and barred while it is hot, the body may shrink while it cools off and produce a shrink fit on the open gate, making it difficult, if not impossible, to open. Pressure drop across a large valve must also be taken into consideration. If the pressure on one side of a closed gate valve is high and the other side is low, the gate is forced over in the guides, and due to this distortion becomes impossible to open. These are two reasons why large gate valves have small bypass valves around them. By first opening the small bypass valve and permitting the fluid to flow around the main valve, you warm the valve, bringing it closer to its temperature when it was closed. You also equalize the smaller bypass valve. Never jam a valve in the open position. After a valve has been fully opened, the hand wheel should be turned toward the closed position 1/2 turn. This takes the pressure off the packing, which would eventually leak if jammed open under pressure. This prevents the valve from freezing in the open position, making it difficult to close. Another reason for not leaving globe valves fully open, it's sometimes difficult to tell if a valve is open or closed. If a valve is jammed in the open position, the stem may be damaged or broken by someone who thinks the valve is closed and tries to force it open. There are valves which are exceptions to the rule of opening wide and then backing off 1/2 turn. These are known as back-seating valves, and a back-seating valve, when in service, should be opened wide. The disc or disc nut has a seating surface on the back side, which mates with a similar surface on the bonnet when the valve stem is in the wide open position. This takes the pressure off the packing. If the back seating surfaces are not damaged, the valve can be repacked while in service. A good example of back seating valves are high pressure gauge line valves, valves which are in high pressure service and are always in the wide open position. Globe valves are normally installed in a line with pressure under the disc. There are several reasons for this. For one thing, pressure under the disc assists in opening the valve. Also, with the valve in a closed position and the seat and disc in good condition, pressure is off the packing and it may be renewed. This, of course, is only true when there is zero pressure on the downstream side of a closed valve. If valve packing is allowed to leak continuously, stem damage may progress to the point where no packing will hold. Then, complete stem replacement is necessary. A leaking stem can lead to a chattering valve. Chatter initiates other troubles within the valve. Vibration extends to the working parts and can damage them beyond repair. It's also possible for chattering to lead to an accidental closing of the valve. In a critical application, such as a pump suction line, accidental closing can cause extensive equipment damage and downtime. When operating any valve, be sure it's in the correct position and that it's the correct valve, and be sure what the effect of its operation will be. If in doubt, do not operate operation. Let's leave valves now and talk about steam traps. In steam lines, steam traps remove condensate without loss of steam. They prevent water entry into the turbine and damage to the blades. In heating system, traps remove condensate and air without loss of steam. They improve efficiency by causing steam to condense before being removed, thus increasing the rate of heat transfer. They also prevent water hammer from endangering the piping and fittings. Traps are used to remove water and oil from airlines, thereby protecting combustion control equipment. In general, a steam trap consists of a valve and control device which will cause the valve to open or close for condensate draining without the loss of steam. Thermostatic traps are usually found in heating systems. They depend on thermal expansion to operate, either by means of an alloy bimetallic strip or by metal bellows partially filled with a volatile liquid. This one is a bimetallic type. Steam strikes the bellows, causing the enclosed liquid to boil, increasing the pressure inside the bellows and thus causing the trap to close. As the bellows cools, the liquid contracts and opens the valve, allowing condensate to pass through the trap. The most common mechanical trap consists of a ball and float valve, which rises and falls with condensate level to open or close the discharge valve. Okay, so much for traps. Let's talk a little about pipes. About the turn of the century, 95% of all pipes installed were cast iron. Since then, piping technology has expanded into an almost infinite variety of materials, fittings, and supports. A generating station has an unbelievable amount of piping, and of course without it, no station. For instance, one piping system carries fuel to the boiler, a second piping system supplies the boiler with feed water, a third piping system carries the steam from the boiler to the turbine and other points where needed. Still other systems carry oil for lubrication and control, water for cooling and lubrication, air for soot blowing and combustion control, and on and on. The list is seemingly endless. The nature of substances carried in pipes, as well as the nature of services performed, makes it necessary to use a variety of materials, sizes, and designs of piping and fittings. A pipe is made of metal such as wrought iron cast with standard iron pipe sizes, IPS, expressed in inches or fractions of an inch, from 1/8 inch to 12 inches. Basically, pipe is designed in 3 grades or weights of wall thickness, as standard, extra strong, or double extra strong. The outside diameters, OD, are the same for each of the 3 wall thicknesses of any pipe with a given IPS dimension, while the actual ID of these pipes will differ. When the inside diameter measures more than 12 inches, the pipe is designated by its outside diameter, or OD. Tubing, unlike pipe, is designated by its nominal outside diameter. Wall thickness is specified in decimals of an inch. Tubing is joined by such methods as flanging, rolling, welding, soldering, or brazing. Because it has thinner walls, tubing is much more flexible than the thicker-walled pipes. The term alloy is used in connection with various types of metals. A metal is said to be an alloy when it contains other metals in addition to the principal one. Alloy steel pipe in high-pressure temperature applications permits thermal efficiencies not dreamed possible some years ago. Not too many years back, turbine throttle pressures of 900 psi and temperatures of 900 degrees Fahrenheit were considered high for power plants. Today, there's a unit in operation with 5,000 psi and 1,200 degrees Fahrenheit fed through modern alloy steel pipe. This thick-walled high-alloy pipe must be given the same consideration afforded boiler drums or turbine metal. Headers must be warmed, limiting temperature rate of rise to specified limits. Excessive repeated thermal stresses can result in cracking of metal. Many volumes have been written about piping and uses of pipe, but for our purposes, you've been introduced at least to some of their uses. Now turn to page 18 of your booklet and complete the quiz on part 2. The test continues on page 19. Page 19 also contains space for notes or questions you may have and a listing of books on the subjects of valves, traps, and pipes, which you may like to jot down for future reference or reading. Number 1 is true. Tubing is designed for size by 12 inches. For number 2, true. A metal is said to be an alloy when it contains other metals in addition to the principal one. Number 3 is false. The 3 grades of pipe are standard, extra strong, and double extra strong. The normal strength pipe is classed as standard, not strong. Hence, the statement was false. Number 4 is also false. In pipe of a given size under 12 inches in diameter, it's the outside diameter of all 3 wall thicknesses which is constant. The inside diameter will differ depending on wall thickness. It is true that tubing may be joined by such methods as flanging, rolling, welding, soldering, or brazing. Pipe will usually be joined by flanging or welding. True for number 5. Number 6, false. The thermostatic trap depends on thermal expansion to operate. The most common mechanical trap consists of a ball and float valve which rises and falls to operate the discharge valve. If you said true for number 7, sorry. An open valve should be opened and then backed off 1/2 turn so it will close more easily. But a closed valve should be closed tightly and not left to leak, thereby cutting the seating surfaces. So number 7 is false. Number 8 is also false. Whether it's operation of valves or any other equipment, this statement would be false. If in doubt, do not operate until doubts have been cleared. This is good sound advice in any situation. The last question is true. A bypass around the valve is used to equalize pressure on both sides, so the valve will be easy to open. The bypass also allows the entire valve to be warmed to the temperature it was when it was closed. Well, this completes valves, traps, and piping. And if you'd like, you can repeat this film or both films. Or otherwise, the next time the machine stops, put in your next cartridge and go on to the next lesson.